I'm on DX Quick Start Session 0. Uh, we did simple models on how we are going to create the very simple risk factor model, create environment, pass on some values to that environment, use models like GBM and Black-Scholes, and predict the underlying and predict the value of call and put and option Greeks. Now I'm jumping to something, and then we also looked at a Sabre model where we want to first project this kind of volatility, which we start from 1 and then we would say that it's going to spread across and increase as time goes by. So if you want to go a lot far, then I'm not going to use the same volatility that I'm going to use after 1 month and so on for the strike prices. Uh, but anyway, let's look back and come to the current topic, which is options portfolio. Many options in one portfolio. So in a portfolio class, we need to add information about model and classes to be used to the market environment of the risk factor. In market environment 1 and in market environment 2, we add a constant called model as GBM. To compose a portfolio consisting of just a defined option, we need to define derivative position. Note that this step is independent from the risk factor model and option model definition. We only use the market environment data and some additional parameters like payoff function. Let's see. If we say that we want to define a put or a call, we would say that dx dot derivative position, that's our position that we have taken in one of those options, and we'll say that the name is put, and we have two puts. The underlying is GBM, the market environment is OPT, the option type is American single, and the payoff function. So this is like having two puts and taking a position of two puts. So it's like you are invested in these two puts, you bought these two puts, and that's your position. Now we are taking call positions, and we say that dx dot derivative underscore position, name equal to call, quantity equal to 3, underlying is GBM2, market environment is equal to MEOPT. If you don't know MEOPT, I'm going to just repeat you. So the market environment option is defined here. So this is the valuation model. We say that the OPT ME underscore option market environment is taken from the price is taken from the pricing data. The other environment, like the underlying price and all those kind of stuff, is taken from the origin. So we are using the old stuff again and again and again, and then we add a maturity, and then we add a strike. So the underlying was 100 and the strike is 110. Where was the underlying 100? It was here, which was the initial value. We should make sure that it's initial value and use the same names in string when we do that. So after doing all of this stuff, we are finally at the position where we can define the put and the call that we own in our portfolio. Now let's define relevant market by Python 2 dictionaries and correlation between the two risk factors. So we say that the risk factors are GBM underscore 1 and GBM underscore 2, market environment 1, market environment 2. This is because we could have different market environment. Let me also quickly go back and show you what is market environment 1 and market environment 2. So this was the market environment 1, and in the market environment 2 we had increased the volatility to 50%. So market environment 2 was like more volatile. So these are the two market environment: a less volatile market environment and a more volatile market environment. Then we have the correlation of the risk factors. Then we have the position, and then we value underscore environment, and we say that this is another market environment. This is general, frequency, weekly path, starting date, and we are getting it from VAL underscore ENV dot pricing date and the final date. And the discount we are getting from R. If you remember, we defined this R short as the short rate 0.01% for our model. So this is a valuation environment, and we started this environment with like general string passed on as the first argument. If you remember what we passed on the first argument here, it was market environment. Here it was market environment 2. So now we are using general. Okay, then we say that this is the date time of that environment, because everything is time series, so we have to keep that thing in mind, that everything is for a point in time. Then we have the frequency, the path, the start date, VL underscore pricing date, VLV underscore pricing date, and the discount rate curve. Now these are used to define derivative portfolio. So this was the market environment, dx.market environment, and this is the derivative portfolio, dx.derivative portfolio. So name is portfolio, position is equal to positions, which is this, which is these two positions which were defined, which came all the way from these two blocks as here, as a dictionary, and we have to mimic them. We cannot do anything. We have to mimic them and put them into dictionary and pass it. Then we have the valuation environment, risk factors, these two risk factors in the same order, and then we have the correlation between the risk factors, and we don't need parallel valuation. So let's see if we can get that. We forgot to define some of these ones. So I'm running everything and hoping that maybe I need to run everything from the starting, but let's not worry about that. Let's see the old output. So when we do that and we write portfolio.get values, we get these position, and right now the position value is this, and this, and the value is this, and then we can get the two statistics like position value, position delta, position vega, and then we can write the risk report on the delta and the benchmark value. So I'm going to go a little slow here. So coming back to what we did, again we defined two market environment. One is low volatility, one is high volatility, and we started in low volatility from 0.1 and in high volatility from 0.5. Then we define these two positions by dx derivative underscore positions. Then we define these two risk factors, because the market environment is really the risk factor. Then we define the correlation between these two risk factors, and we give them geometrical Brownian motion 1 and geometrical Brownian motion 2, and we define the position of put and call. If you remember, the put and call here is the put and call for the same underlying. We did not change the underlying yet, so be reminded. And then we created this valuation underscore environment, and then we ran it here in the derivative underscore portfolio, and using that we created a portfolio so that we can get the values of what exists inside the portfolio. Then we have the option type, risk factors, value, currency, and position value for that one, and the position and the name of the position, and we got the position value and the value. And let me go back here and see if I can get you the same before we run that. So you see here the present value is 15.013, and you would see that 15.013. So that's the same value of the call and the put option, and similarly here it's 20. And then we have the position value statistic, which is 91, which is the sum of these two. position delta and position vega. So I hope this was helpful. I'm going to move ahead and talk again on this later. Thank you for watching.